Hello, everyone. I'm Dr. An. AI is a hot skill on the job market, but learning AI is no simple task. There are 5 common misperceptions which prevent many people from learning AI, including too much math and statistics, too much programming, AI needing too much data to become useful, AI requiring computation resources that are too expensive, and also the notion that I can't compete with professional AI scientists on the job market, no matter how much I learn. In this short video, I will argue against each of those 5 misperceptions with hard evidence and personal experiences so that we can clean those negative mentalities out of our way. Let's dive into it right now. Hi, everyone. I'm Dr. An. Today, I would like to talk about common misperceptions and misunderstandings about learning AI or self-learning AI. There has been a surging demand in job market for interdisciplinary social, behavioral, and health scientists who also have modern data science, data analytics skills. So the current national average annual salary for a data scientist is about $120,000 in the US. In addition, the US Bureau of Labor Statistics predicts that data science jobs will increase by another 28% or 11.5 million through 2026. While the job market looks all rosy, there are actually a lot of common misperceptions that serve as barriers to social scientists or health scientists from learning AI or self-learning AI. Today, I would like to talk some of the common misperceptions that I often face when talking with potential students or professionals who want to learn AI but have a lot of concerns. So one common misperception is that AI demands a lot of math and statistics. If you don't have a solid college level or even master level mathematical or statistical background, you better stay away from AI. Another common misperception is about too much computer programming. So if you are not a computer scientist, you have not seriously considered programming, then you should not learn AI. Third conception or misperception is about AI demand a lot of data to be able to train a model that is useful. The data collection is tedious and often demand a lot of resources since we don't have a lot of data, images or text or other type of data, then maybe we shouldn't learn AI. The fourth misperception pertain to computation resources. People often believe that the AI models require a lot of GPU-powered computer, and those devices are very expensive. No, I don't have that budget to buy an expensive GPU-powered computer, so I shouldn't learn AI. And the last one, but not least, is that, I can learn AI, but no matter how hard I learn and how much I learn, I still can't compete with professional AI scientists who were trained with a PhD in computer science or engineering or data science or artificial intelligence on the job market. So if I can't compete with them, no matter how much I learn, no, I shouldn't learn AI at all. So those are the 5 very common misunderstandings and misperceptions about AI. And now let's dive into my arguments against each of those perceptions or barriers. So first, let's talk about too much math and the statistics associated with AI. Well, on the one hand, yes, AI has a lot to do with mathematics and the statistics. Many of the AI models use complicated mathematical algorithms or statistical properties to derive some meaningful results. But well, on the other hand, I would say most AI practitioners who use AI as a tool rather than developing new AI algorithms, they don't bother learning those underlying mathematics or statistics. Probably 99% or more of the AI practitioners, they don't need to know the advanced math or statistics to be able to apply AI algorithms. So on the other hand, well, intuition and real-world experiences of AI application probably are more important on the fundamental than mathematical or statistical proficiency. No, but I really don't need students to derive the bias variance trade-off equation because that is not essential. What is essential is really to understand what are the contributors to biases and what are the contributors to high variances and how you can balance between these two properties to derive a model that is useful in practice. So therefore, the intuition and experiences working with those models are probably more essential than being able to derive the equation or prove the bias-variance trade-off mathematically. And to a lot of time, actually, modern AI is more of engineering. Basically, you want to work through the trial and error, try to improve your models rather than theoretical mathematical proofs. Because, well, most of those AI components, actually, they are fairly straightforward. And I often use analogy of Lego. So each of those AI building components is like a Lego piece. And although those Lego pieces are with variety of shapes, but they are simple, they are easy. But then if you innovatively build using those Lego pieces together, you can build arbitrarily complicated AI models. So therefore, you won't have to know all about the math to be able to use those Lego pieces to build something useful. And now talking about the argument or misperception of too much programming. Well, of course, on the one hand, you do need to know programming, for example, programming AI in Python or other APIs. So basic understanding of computer programming is definitely needed. But on the other hand, well, AI programming has been made increasingly simpler and easier thanks to Python and many high-level APIs. For example, here I show you, you only need actually 2 lines of code to program a state-of-the-art random forest regressor. And you only need 3 lines of code. The first line of code is to create a sequential deep neural network model. The second line is you compile that model using the optimizer, define a loss function and matrix. And the third line is to fit that model on your data. So, and not to say there are many zero code or no code APIs available that allow you to design and implement complicated machine deep learning models without programming at all. So to address the third misperception regarding you need a lot of data, too much data to become useful, well, to the one hand, it is true because many of the computer vision and natural language processing models, they need a lot of data. They need millions of images and probably billions of text to be able to train the model. But the good news is thanks to transfer learning, now you won't have to train your model from scratch. Actually, few people nowadays train their model from scratch because they can always use those computer vision models trained on millions of image data set and those natural language processing models with billions of parameters already trained and optimized and using, say, all the data from the internet. So therefore, you can use those models for free most of the time, thanks to open API such as Hugging Face and PyTorch. And so you are not building the model from scratch. You are standing on the shoulder of giants. And that greatly simplify your work. Both you don't need to build the model architecture, and second, you can train the model using the pre-trained weights from those big models that are already trained, so that it demands a lot less data for you to fine-tune model that works great. For example, instead of using 40 million images from the open image or ImageNet dataset, you only need probably a few hundred images to make a computer vision model for classifying images or detecting objects in the image or segmenting elements from your image. So that is because, you are utilizing the transfer learning, which allow you to stand on the shoulder of those giant foundation models. For natural language processing, also, you don't need to train your data using the whole Wikipedia text because that has been done. You only need to borrow the model that was trained using that data to do some downstream task. For example, you won't have to have data at all. So that is called zero-shot learning, or you can have very few data points called few-shot learning. So here is an example using GPT-2 model as it is. I do not train or fine-tune the model. So I provide the prompt to the model. Life is like a box of chocolates. And let's see how the GPT model is going to complete the sentence. It writes, it opens into itself. It fills it with life. And it's all about sharing. Beautiful, right? So this is absolutely a beautiful sentence created by GPT-2 model without any fine-tuning. And the fourth misperception is about, computer natural language processing model or computer vision models, they need a lot of computation resources, such as, for example, GPU. So it's too expensive, I can't afford it, so I should not learn machine learning and AI. That is true that most of the deep learning models require GPU because the parallel computation is a lot faster than CPU. But on the other hand, you don't need to purchase a GPU-powered computer. There are many resources online that allow you to use free GPU computing. For example, the Google Colab and the Kaggle, they offer free GPU. And if you want to do more complicated tasks, maybe with multiple GPUs, with more computational power, you can also pay a little bit for cloud computing using many of the cloud computing platforms such as, for example, Google or AWS or Azure. So pay as you go. So for example, nowadays I don't even have a GPU computer, but I always store my data on the cloud and also do the computation using Google Colab or other online tools. You really don't need to have a computer. You can even use your iPad or any other crappy devices. As long as you can access the internet, you can access the cloud computing platform, then you can do your computation and data manipulation there. And the final argument is that, no matter how hard I learn, I still can't compete with professional AI scientists on the job market. So what is the point of learning AI after all? That is probably true that, a person who self-learn AI may not be able to compete with a PhD in data science or a PhD in computer science or artificial intelligence. But, the good news is that you may never need to. Because the job market is highly segmented, and market really value people with interdisciplinary background. For example, you have your own profession. You may be a public health professional. Maybe you are a social worker. Maybe you are a nutritionist, or maybe a physician or a nurse. No matter what your profession is, the job market highly value if you know your profession, but at the same time, you also have some data science skills. So basically, you are an interdisciplinary data scientist. And you are not really competing in your own profession with people with a PhD in computer science or PhD in AI. You are really competing in your own much field with other public health professionals, with other social workers, with other nutritionists, etc. So therefore, because of the segmentation of the job market and specialization, you are not really competing on the general job market regarding developing new AI algorithms, but really you are competing, and you do have an advantage if you have learned AI and being able to apply those state-of-the-art artificial intelligence models in your own profession and in your own tasks. So let me recap and make a summary. There is an increasing labor market demand for interdisciplinary data scientists, basically professionals who not only know their own domain, but also being able to apply modern data analytics and AI on their own professions. On the other hand, there are some common misperceptions regarding AI or self-learning AI. Too much math and statistics, too much programming, needing too much data and computation resources, and not competitive against professional AI scientists on the job market. And we have made counter-argument against each of those misperceptions and barriers. And AI may be easier to learn than you thought, owing to open source higher level APIs and advancement in cloud computation. So I would encourage you to start learning AI sooner rather than later. Thank you so much for your attention. I'll see you next time.